Hi, thanks for coming. I'm Sean. I'm working in Powdr. So today I'm going to introduce Powdr to you. And Powdr, in short, it is a tool to help developers build zkVM and also help people to generate zero-knowledge proof for the program that's written in high-level programming language. So during my talk, I'm going to guide you through the approaches people generate zero-knowledge proof and the approaches people take to create zkVMs and why it matters, and also to explain you why Powdr it is changing basically the landscape of zero-knowledge proof development. We start with some basic concept. So to think about the different approaches people take to generate the zero-knowledge proof, we basically have two approaches. The traditional one is you write your circuit, handwritten circuit, and this circuit is for specialized computation. And you generate a specialized proof. This proof is only valid for this computation. And for this track, we have zkVM and Socrates. Another approach is zkVM. zkVM circuit, emphasized here, zkVM itself in the circuit, because when we talk about VM, it is a program that can take input of a program, and VM it can understand how to run this program. Because VM itself is a program, and in ZKP setting, every program can be translated to a circuit. So here, zkVM itself is a circuit, but it can understand how to execute the other circuit. So your input is the circuit. Then it can generate a proof, and this proof is, if the proof is valid, it means your zkVM executed correctly. This also implies that the program you put inside the zkVM also executed correctly. This basically scale up the proofs for that. Whatever program you can run in zkVM, you can generate a proof for it. I would say this approach is one level higher than the approach of write a specialized circuit. You can think like if you write a specialized circuit for specific computation, you need a verifier, specialized verifier that can only take proof that for this computation. But for zkVM, whatever programs can run on zkVM, you just use one single verifier that can verify the execution of the zkVM. If we make an analog here, circuit you can see it as an OSIC. It's a specialized computation chip. And zkVM, it can be a CPU. So as the benefits of using zkVM, as I said before, the scalability, because you only need one verifier. And another benefit is, I would say zkVM developing kind of separate the development resources to do two different groups. So we will have people that specialize, dedicated team to develop zkVM circuit. And for application developer, like smart contract developer and the DApp developers, you only care about write your program in a high-level language, in Rust or Go, C++, whatever. And you don't need to have any knowledge about zero-knowledge proof itself. So it's much more user-friendly. So to understand the role of Powdr, I needed to elaborate some programming language background, basically how in a typical virtual machine setting, not zkVM, how a Rust program or any program that's written in high-level language gets compiled and executed in a low-level machine. So we have a program written in Solidity or Rust or Go. And the first step is it's compiled to an intermediate representation. It's kind of assembly-like language, and the important thing it is platform independent, which means that after it transferred to this IR, you can use this IR to translate your code to different VMs. It's x86 or RISC-V or ARM, whatever you like. And I would say the IR nowadays is most LLVM is the starting point of the whole compilation works. There will be a lot of optimization happening here, like to improve the performance or reduce the memory usage. LLVM now is very popular because of its flexibility. It allows you to have a different high-level language, and it supports multi-platform. Multi-platform here is a different architecture of the VM. And also it has a lot of optimization choice. So the question comes to what is this process in zkVM setting. Just to emphasize the importance of LLVM and how it helps the development. In zkVM setting, this is the ideal scenario, I would say. We also wish to have a high-level programming language, and we wish to have this zk compatible intermediate representation. I say it is zk compatible because when you write a program in high-level language, there are some certain operations that they are not zk friendly. For example, we have some primitives like hash functions. If you talk about Poseidon and the rescue, these are much more zk friendly. When you want to transfer a hash function to a circuit, Poseidon or rescue, they can be much smaller. You can like 200 lines of code, you can implement it. But if you use a hash function like SHA-3 or SHA-256, it will be much bigger. And if you want to have a smaller circuit, in this step you might do some modification to change some hash from not zk friendly to zk friendly. But this is our ideal scenario. We have this intermediate representation, and it is platform independent. Then you can use it to translate to different architectures of the VM. This basically means you map the IR to a specific instruction set that's based on what architecture you choose. And because we are in zkVM setting, we need to give a proof, and to give a proof what we need constraint and witness, or you call it execution trace. And so we need to have a polynomial language to transfer these instructions to polynomials to the constraint we find in a prover, and then we can you can use snark or start to generate a proof. And this is the ideal scenario. So it's much clean and straightforward. But what we say we actually have in the zk development landscape now is more looks like this. So there are many zkVM projects, and much more than what I showed in this picture. I would say each of the projects will take their own approach to develop zkVM and be kind of independent of each other. So it looks like a bit messy and chaotic. The question comes, as a developer, if I want to transfer my application from one platform to another platform, That means I might need to use a different compiler stack because this project might have their own special compiler to transfer the high-level program into their, like for example, Carol, they use this readable Carol intermediate representation. And apart from a compiler stack, you also probably need to learn a new language. This is specialized DSL language. And also you need to make your instruction be tailored to a specific zkVM architecture. At some point, it's more like you are shaping the whole code base to another platform, and you need to create it from scratch again. This is a really big problem. If we make another analog, we think about the people developing games like 20 or 30 years ago. The games are written in assembly language. When you want to transfer the game you develop from one platform to another platform, you really need to change your code to match the specific instruction set, and also learn how to do it, and then just start from scratch. This is how we see the zk development nowadays. It really looks like this. So this is the problem Powdr want to solve. Apart from developer need to start something from scratch, also there will be this disadvantage when you talk about auditing, you talk about optimization. So Powdr we want to solve this problem, and we wanted to create something similar to LLVM. That is an intermediate representation. It's a new language, and it is platform independent. So you can use this language to transfer your code to different platform. You can have a different front end, different high-level language, and they all transfer to this IR. And then you can use this IR to transfer your code to RISC-V or UVM or JVM, whatever you would like. So this is our vision. We wanted to make the zkVM development be close to the standard programming compilation process. So in order to do this, our compiler engineers create this new language we call Powdr assembly language. It has this important characteristic. It's a low-level language and platform independent. So you can use it to create your own zkVM. It can be RISC-V, EVM, or other customized zkVM. I would say like Powdr's approach to build zkVM is kind of one level higher than other projects because we are here, we create a language to allow you to define zkVM, but other projects they might fit more here because their language are specific for their own zkVM. Their zkVM is kind of developed for specific prover as well. You either use Stark or Snark. And we also have this PIL language to translate the code to polynomials, and then you can put the polynomial constraint together with the trace to generate a proof. PIL originated from Polygon PIL. But our compiler engineer added more things to it, and at the end we kind of create our own. The last point, but it's also very important, another very strong feature, flexibility feature we add is you can choose the prover you like to prove your zkVM. This is a unique feature. Now the zkVM is either you use Snark or Stark, but Powdr you can choose the prover you want to use. This depends on the current available prover that's on the market we can use. We try to integrate it to Powdr system. Now we have a Hello 2, Plonky 3, if Stark, and Stu is under integration, and this is my work mainly focusing on. In the future, we would also integrate some very promising provers like you heard Venus and Nova. I think this allows you to have multi-prover is more future-proof. Like if at some point you really need to care about post-quantum secure, then all the system built on Snark, they need to transfer to Stark. And if you don't want to transfer everything from scratch, you can start to use Powdr, and then you can transfer it smoothly. Basically, you just choose, at the end, you choose, I want to use Stark to prove my system. And yeah, so I like to show this picture because these are different zkVM people build, and they fall into the category of Stark and Snark, and Powdr is kind of a unique non-binary option. So the conclusion, like if it depends on what you want to do. If you are a zkVM builder, you can use Powdr to build zkVM, and then you only need to focus on the high-level architecture, make it easy to write, read, test, audit, and verify the implementation. Powdr automatically do the weakness generation and constraint for RISC-V 32 MFVM, which is just 300 lines of code. And if you are a DF developer, you just write your program in a high-level language. Powdr can be a drop-in replacement for your compiler stack. We like to say you write once and prove everywhere, because you can prove in different platform and use different prover. This is a code of an example written in Rust. It's a Fibonacci example. Now we already in Powdr, we already use Powdr assembly to define RISC-V virtual machine. So this code written in Rust can compile to RISC-V, run on RISC-V zkVM. Yeah, these more features. I would like to do some code demo, because last week we just announced our Powdr 0.1 version. Is basically we create a template that when you want to use user, you can just use the template to generate a proof. In this setting, normally we have a guest program. This is the program that you want to generate a proof for, and the host program is the zkVM. This is the template repo. Here you, let me just run it. I downloaded it already here. And then I will open it and have a look. Like I want to demonstrate. How the assembly language looks like, and how the pill, which is the polynomial language, looks like. Here we have the guest program. Do I need to zoom out?
Yeah.
This. This is a simple program. This line is read some data from the host machine. It's the zkVM, and then do a simple addition. This is the guest program we want to give proof. And in the main machine, there will be some data generated, and the guest machine used to do the addition. So here I needed to accommodate. This means I want to generate a proof. I also wanted to change the code here to it's the same code but just optimize the version. See on the left side now we don't have much things.
What's the difference between this word and the common code and this?
They are doing the same thing, but the commented one, it generate proof in one stage. But now I'm using this code, it can separate your proof to several stages, so it's faster. There's some more.
I think you forgot to save. No, you forgot to save the change, so it will rerun the code before. You
can save the document.
Start again?
Yeah.
Yes.
Yeah, now we can say this is the assembly code. It generates the program on the running zkVM. This is how it looks like. Now here you define the registers. Do the bootloader. These links are some thing related to lookup. And the pill is starts to become polynomial. It's messy, but it's all just the polynomials. Okay, some equations need to be satisfied. I think this is my demo. Any questions?
What's next? Now you get this polynomial. How to use that?
it already it is generating the proofs based on these polynomials.
Oh, I see.
Yeah.
You use Powdr to generate different proofs such as for different VMs. I see.
Yeah. Now we want to have a risk bias. We are trying to develop more zkVM, and then for different zkVM, we just use the same interface, and it's all compiled to pure polynomials, and then you choose the prover to generate proof for you.
Such as if I want to generate a proof for Stack9, so I need to write a compiler to convert this format to the format they use, right?
It's Stack.net. They have their own virtual machine,
Yeah.
like a Powdr virtual machine. What you need to do is you need to use this assembly language to define a Stack.net virtual machine, and then you write a program. It can generate the proof that can be accepted by Stack.net.
What do you mean the Stack9 virtual machine? So you mean I need to implement the zkV, the KVM?
Yeah, using this language, because it's a language to define the KVM. It doesn't have any built-in VM. But like if more VMs we make in this Powdr assembly language, that means a developer he just write one program and then you have different virtual machine to choose. This, if someone interested to implement Powdr VM in Powdr, or we plan to do it in future. Yes.
Does it currently support private inputs? Because right now I think KVM is looking to support private inputs via hints. So does Powdr allow you to write a chiral diagram and not just input, like whereas zkVM that can allow for private inputs in their guest programs? So something like what AU is doing, basically their VM in their language, the DSL allows for private inputs to be computed. Can I write something like that?
I think so. Private input, if that means that committed witness.
Sorry?
Committed witness. Like a private input and then it We're talking about public input. That's not a specific issue because of Plunky 3.
Thank you.
So can I say Powdr is the most advantage of Powdr is to make a developer to much easier to develop some different zkVMs. Okay, I see.
It's like you use this Powdr assembly to define a zkVM, and then because this assembly, it's easier for you to audit your zkVM implementation. But you can still create use your own tool to create a zkVM. But then if everyone do the same thing, how are we going to audit it? Because everyone use different tool, right? But if like we have a universal tool as a Powdr assembly, it's much easier for people to audit, do optimization as well.
Okay, so all the toolkits cannot work with other ecosystems such as Stack9, SP1, Polygon, such as Maiden, those VMs.
It needs to define their VM in Powdr first, then they can use.
Define means I need to implement that.
Yeah, you like if you want to use RISC-V by SP1, you check their instruction set, and then you use Powdr assembly to follow the instruction set and to define the whole zkVM, and then it becomes
Then you guys are compete with this the whole the whole zkVM ecosystem, right?
It's not compete. I would
Uh-huh.
say it's like
Because you cannot work with them. You can if I use your toolset, I can use theirs, right?
the thing is, if for someday, like if an approver just went snark or stark, the one track get very compete with the other. And at that time you use a wrong approver. You use a not optimized approver. And if you use Powdr, it's much easier to switch. I think this is your question.
I think it's still different ecosystem.
I see it's improvement, not a competitor.
Have you benchmarks on performance, like compared to the other zkVM, or do you think it's not able to compare with them because you are doing differently?
We are doing benchmarks.
Okay.
It's still ongoing.
Okay.
It can be comparable.